Technology for cut protection has advanced over the past decade. That's why the testing standards have to as well. A revision to the EN388 standard for glove, giving protection against mechanical risk, including cuts, will come into effect in 2016. As a leading material science company and an active member of the technical committee charged with revising the EN388 standard, DSM Dyneema is proud to be part of this change for greater safety standard. We would like to take this opportunity to explain and demonstrate these critical changes on cut-resistant testing to safety professionals and the personal protective equipment industry. Firstly, a little on EN388 standard. It is the de facto standard used and referenced in most parts of the world. It describes the test methods and requirements for classifying protective gloves according to abrasion, cut, tear, and puncture resistance. In the latest upgrade of the standard, you can see that an ISO 13997 cut resistance test has been added. This is due to advances in materials used to make cut-resistant gloves and the need to implement common testing methodology globally. DSM Dyneema welcomes this important evolution as it will increase the accuracy and reliability of testing on material with higher cut resistance. It will enable a clearer and more consistent understanding of the true cut resistance properties in a protective glove. And it will help safety professionals and end users make more informed choices about the product they purchase and put the safety of their hands in.
The current coupe test method uses a rotating circular blade and has limitations for testing samples with dulling materials such as glass fiber, steel fiber, and also advanced fibers like Dyneema diamond technology due to the dulling of the blade. Several changes will be implemented in the EN388 2016 standard. Now, when performing the coupe test, the sharpness of the rotary blade will be a key factor. If the rotary blade is dulled by the test sample, then the ISO 13997 test is mandatory and the coupe test becomes an optional test. If the rotary blade is not dulled during the test, then the coupe test must be used and the ISO 13997 test is optional. The coupe test will also be limited to a maximum of 60 cycles. The ISO 13997 test can be conducted using a TDM 100 thermodynamometer. It can also be used for the ASTM F299215 test as well. The TDM 100 uses a rectangular blade from a specified manufacturer to cut across the sample material at a constant speed and force. The sharpness of the blade is calibrated to provide an accurate measurement. Now, let me demonstrate the full ISO 13997 test with an ultra-lightweight 18-gauge cut-resistant glove made with Dyneema diamond technology 220 DTEX fiber. After conducting the calibration of the blades, we mount a test sample on the mandrel. We start by placing the required weight on the pen and performing one cut to get the cut stroke length. The blade is replaced with a new one for every cut. Cut through is determined when electrical contact is recorded between the blade and the copper conducting strip beneath the sample. We need 15 readings that can be distributed between the three categories of cut stroke lengths, with 5 readings per category from 5 mm to 50 mm. This is repeated over at least 15 times to get a minimum of 15 readings for creating the plot of the force against the normalized cut stroke length. An additional 5 cuts should be performed at this reading at 20 mm length to refine the plot as required by the ISO 13997 standard. Based on the plot of the force in newtons against the cut stroke length, we obtain the cut score by reading the force required to produce a cut stroke length of 20 mm. Based on the plot shown, We have a reading of 6.7 newtons for the ultra-lightweight 18-gauge glove sample made with Dyneema Diamond Technology 220 DTEX fiber, which is free of glass and steel fiber. This is at level B in the new EN388 2016 standard. According to the new EN388 2016 standard, cut levels are defined from A to F based on the following scores. This helps end users assess the type of cut-resistant protective gloves or sleeves suitable for their work requirements. In summary, the EN388 2016 standard will provide a more reliable, consistent and accurate cut resistance test with the introduction of the ISO 13997 standard in view of material advancements. The new labeling on gloves will provide extra clarity about which cut test has been used to validate the glove. Glove users will therefore be in a better position to judge which is the right glove for the job purposes. Next time, when you purchase a pair of cut-resistant gloves, look out for the new EN388 standard and ratings. Here's Dr. Jean-Claude Cano, who will tell you more.
In early November 2016, the revised EN388 standard will be published and implemented. By then, notified body has 6 months maximum to adapt their testing facilities. However, we see that a lot of laboratories have already fully prepared this change. Several glove companies are ready to have product launch according to the new EN388 with the new markings. It will be important for glove company to explain to the end user and safety manager how this change in EN388 works and what the new markings mean. It is certainly a big milestone for the industry. I am confident that the industry will benefit from the more accurate and representative guidance regarding mechanical cut protection for the end users.